With the development of many years, the product is getting smaller and smaller. Circuit design is also becoming more complex. High-density integrated electronics like cell phones. The circuit paper could be the size of a table on a flat surface. Such a complex circuit wiring. And how did it fit into this little motherboard? This is a PCB board. It started out as a giant copper-clad sheet. The upper and lower layers are electrically conductive copper. In the middle is a non-conductive Fe4 fiber. At first, it is simply cut according to the demand, smooth all four sides, then attach a photosensitive dry film above and below. Next, use the designed circuit diagram. First, use PCB wiring software to convert it into circuit board wiring. Test the software with DFM. After testing for short circuits or anomalies, finally output a Gerber format circuit file. Then print out the upper and lower sides of the film with the lines. Put the PCB board with the dry film in the middle. Ultraviolet light penetrates the film, the part of the line that's being illuminated. This part of the dry film will cure. The uniradiated dry film is then dissolved with a developing solution, exposed copper phase. It is then dissolved in an etching solution. The copper that leaks out will be etched and cleaned away. Then the film is removed. The rest of the copper wire is the wire we need. Finally, enter the machine OE detection. Run it against the lines in the file. Check whether the circuit is intact. Mind you, complex circuits like cell phones, one board is not enough, must have multiple layers of wiring. When designing a complex circuit, it is divided into an outer plate and an inner plate. Put all the inner plates first. Follow the above steps to make all of them. The machine browns first. The purpose of this step is to coarsen the surface, increase the bonding force between layers. Add PP pre-pregnant tablets in the middle. Put copper foil on the outermost layer. Then enter the high temperature and high pressure machine for lamination. Next comes to the drilling process. Drill holes through each layer and the location of the attached components, the position of the pin of the welding component, and so on, all drilled in one go. Notice here, there is no metal conduction inside the whole wall. So the next step is chemical copper deposition and copper plating. Dense copper is formed inside the pore wall. In this way, the layers are connected to each other. Now we are left with the outer circuit. Start with the same steps as the inner board. A photosensitive film is applied and the hardening circuit is exposed with film. Notice this time the film is the opposite of the inner plate. Start by exposing locations of the line. Use the developer to wash the uniradiated light film of the line, exposing the copper face of the line. Next, the leaked lines are graphically plated, and the outermost layer is tinned for protection. Finally, it goes into the etching machine to wash away the unwanted parts. The external circuit comes out. And finally, protection. Start with antiperspirant ink. Again, with film exposure. Cover the position of the pad, so other than the pad, it solidifies on the plate after exposure. The unexposed areas are then dissolved, using the solder stop developing process. At this time, the pad and pad will be exposed. The rest is screen printing brand and symbol text and other information. Here the artistic journey of a PCB circuit board is complete.